Hi everyone, today we're going to talk about arcs and chords, more pieces of circles that we need to learn. So the terms that we're going to talk about today are a chord. I think we've already talked about chords a little bit maybe, but a chord is a piece of the circle. It's a line segment that goes from one side of the circle all the way across to the other side of the circle. So a diameter is a chord. I could also have a chord that connects like A to B. That's a chord. So any chord that has any segment that has ends on the circle. An arc is a distance around the circle. So an arc might be BC right here. That would be an arc. We could also have like a semicircle is also an arc of the circle. So any distance around the circle. We have a major arc. Major arc would be one like if I went from A to B through C. So it's greater than 180 degrees. That would be a major arc. A minor arc would be the arc from A to B that does not go through C, that is a minor arc less than 180 degrees. And then obviously we can have a semicircle, which would be the arc that is exactly 180 degrees, would be a semicircle. The next term is a central angle. A central angle is an angle, we've already talked about these two, that forms at the center of the circle and has radii for sides. So this central angle AOB, this angle AOB is a central angle. Then we have some theorems about arcs and chords and central angles. Okay, they can be confusing, but they kind of make sense if you think about it. And this is true for if it in the same circle or congruent circles. So down here I have my congruent circles, that circle P is congruent to circle M. And up here I have my same circle. So we'll take a look at these in both of those cases. So it says here that congruent arcs have congruent chords. So if I wanted to look at this one in this circle up here that I had. So what I could say if I'm talking about congruent arcs and congruent chords is I could say that in this circle, that if I were to draw, like another, let me do it somewhere else. If I were to draw another central angle that is 40 degrees. So those have, and so those central angles, well, let's see. And if I told you, let's call this C and D. If I told you that CD, arc CD, that's how we would do that, is congruent to arc AB, then you would know that the chord from C to D, and A to B are also equal. So chord CD is also congruent to chord AB. Okay, so congruent arcs have congruent chords. If you know the arcs are congruent, you know the chords are congruent. Down here in these circles, again, if I know that arc AB is congruent to arc CD, then I know that segment AB is congruent to segment CD because I know the circles are congruent. Congruent chords have congruent arcs. That's just the converse of that first one. Congruent central angles have congruent chords. So since in this figure up here, since I know my central angles are both 40 degrees, I know that AB is congruent to CD. And then down here, if I knew that this angle is congruent to this angle, then I would know that AB is congruent to CD. Congruent arcs have congruent chords. And if I have congruent arcs, then I have congruent central angles. So knowing up here in this figure that AB is congruent to CD, would tell me that those angles are congruent. And then down here in the separate triangles, same thing. If I know that arc AB is congruent to arc CD, then I know that angles are congruent. So, so those are the theorems that go with those. Two of them are converses, so these are converses. The others are not converses. They're just separate theorems. Let's talk about the midpoint. Midpoint of an arc is one that cuts the arc into two congruent segments. So if a point is the midpoint, so for example, if we have arc ABC and you know that B is the midpoint, then that means that that arc and that arc are congruent. And any line, segment, or array that contains B bisects. So if I had a diagonal through here, I would know that that diagonal bisects arc ABC. And we can name an arc, I may not have said that earlier, we can name an arc with two letters if it is a minor arc. If it's a major arc, then we might need a third letter to let us know which one we're talking about. Because if I just, like for instance in this figure here, if I talk about arc AC, well, am I talking about arc AC, whoops, am I talking about this arc AC, or am I talking about this arc AC, right? Whereas if, to be clear about that, if I put another letter here, like a D, on the other end of the diagonal, then if I talk about arc AC, if I don't put another letter in, then I'm just talking about A to C. If I do put the letter in, like say ADC, then it's clear that I'm getting to C through D. So I'm going around this major arc, okay? So keep that in mind. To be clear, sometimes you might need three letters to talk about an arc. A diameter or radius that is perpendicular to a chord bisects the chord and its arc. This one's huge, okay? So, and the converse is also true. So what we have a diameter, or over here just a radius, that is perpendicular to the chord. So here's my chord, right here, perpendicular to the chord. Then it bisects the chord. I know that. So if a diameter or radius is perpendicular, then it bisects the chord and it bisects the arc. Okay? Conversely, if you know that it's a perpendicular, that it is the perpendicular bisector of a chord, then you also know that it's a radius or a diameter. Okay? So that's what those say. Here we have a few problems to work, considering the theorems that we just had. So in this first one, I want to find x and y. So what I know, and be real careful here, I know that I have in this circle that I have a radius. This is my radius, is 13. I've got this little segment here is 5, and I need to know x and y. And I want you guys to remember, turn off the video, think about it for a minute if you want to try it yourself first, okay, on all these problems. So what I might want to do here, well, what I'm going to have to do, there's no way for me to get this just looking at this. I'm going to have to create a triangle. So I'm going to create a triangle, like right there. Now I have a right triangle. This that I just drew is a radius, right? It's from the center to the side of the circle, so it's also 13. Now I have a right triangle. I can use the Pythagorean theorem, and I can see that that's going to be 169 minus 25 gives me 144. So that's going to tell me that y is 12. So y is 12. Now I had that theorem that says if the diameter is perpendicular to the chord, then it bisects that chord. So that means x is also 12. I hope you got that one. Now turn it off again and try B. For B, it's telling me I've got a 60-degree angle here, and it's telling me I've got this radius here of 6. So I need to find x and y. I'm just going to use 30, 60, 90 relations, right? So my short side then is y, which is going to be 3. And my long side of this triangle is going to be 3 radical 3. Make sense? Let's try some more. So over here, I'm looking for RT and MS. So MS is this little piece here. RT is easy, right? Because I know that I have a diameter and it's perpendicular to a chord, so I know it bisects the chord. So RT must be 30, because both sides have to be 15, right? And now I'm looking for MS. Well, remember from O to S is the radius. So I know that that is 17, right? Because here's a radius right here that, that is already drawn. So I've got that radius already. So if I figure out this little piece, I'm going to call it X. If I figure out that little piece, then I can subtract it from the radius to get MS. Does that make sense? So to find that little piece, I'm going to do 289, 17 squared minus 225 is going to give me a 64. So I get that MS equals, so that X is 8, right? That's my X value here. So 17 minus 8 is 9. So I get MS to be 9. All right, for number D, I'm told here I've got this major arc here. This is 220, okay? They've given me the degrees on the major arc. So that tells me then that this minor arc is 220 360 minus 220. So it's 140. So that is 140. So knowing, then you see I have radius OC that bisects this chord. So, that's perpendicular to the chord, so I know that it bisects the chord, right? And I know also that it bisects the arc, right? So, knowing that it bisects the arc, I could then say that AOC, I can say that arc AC is 70. And then knowing that central angles have congruent arcs, I could say that that is also 70 degrees. Make sense? All right. So here's some more. Here's another one. This one we're going to need to draw a picture. This one's asking me for the length of a chord that is a perpendicular distance away, 4 centimeters away from the center of a circle with radius 6. So here's my center. Here's my chord. It told me that it's 4 centimeters away from the center and that my radius is 6. I'm going to draw my radius to here so that I have a right triangle. And it wants to know the length of this chord. I'm just going to call it AB. So it wants to know the length of AB. That's what I'm looking for. So to do this, I know that that is 6. So I'm going to use Pythagorean theorem again. So I've got 36 minus 16 equals 20. Square root of 20 is 2 radical 5. So I get 2 radical 5 for this little piece of that chord. And since I know that this bisects the chord, then I know that my chord is 4 radical 5. Because I'll multiply it by 2. So I hope that makes sense. All right, the final one, not the final one, but last one on this page. We have circle O has a radius of 12. And chord RS is 12 centimeters long. So I'm just going to draw chord RS here. So I drew chord RS there. And I want to know how far RS is. So I'm looking for this distance right here. I'm looking for that. So I know that RS is 12, so that means this is 6 and this is 6. Again, I use Pythagorean theorem and to figure this out. And I end up with 144 minus 36, which is 108. That is 36 times 3. So 6 radical 3 centimeters is the distance from O to RS. Centimeter, yes, centimeters, not squared. And this was also centimeters. All right. So that's how we did that one. And now we have some more theorems. The next theorem says, in the same circle or congruent circles, just like before, chords that are equally distant from the center or centers are congruent. So if I have a circle like this, I have this, and I have like this chord here, and I have this chord here, and I know that they are the same distance away from the center, then I also know that those chords themselves are congruent to each other. Okay? So if I know they're the same distance from the center, then I know that they're congruent. Conversely, I know that if they are the same distance from the center, then if they are congruent to each other, then they are the same distance from the center. So that's important to know. That's in the same circle. I can also have two congruent circles. Remember we said, so if like I have these two congruent circles, let's just say that they're congruent. And I have like a chord here, and a chord here, and they are the same distance away, then I know that those chords, that chord and that chord, are congruent. Okay? Here's a couple more problems that kind of show that, that we can use. So what I'm told in problem G, I'm given that the chord Y is the same distance away from the center, that this chord Y, let me just color it, that this chord Y is the same distance from the center as this chord with the 8 and the X. So they're the same distance from the center. So then I know that they are equal. I know a couple of other things too. I see that this segment here that could be like a radius is perpendicular to this chord. That means that it divides the chord in half. So I know then that X is 8. So if I know that X is 8, then I know that this whole chord is 16, and since these two chords are congruent, I know that Y must also be 16. Sound good? All right, and then finally for H, for question H, again, you guys can shut it down and try it yourself, don't forget. But what I know is that OJ is 10, and they told me that I'm looking for JK, and JK being the length of that chord. I'm looking for the length of that chord. And you might say, oh my goodness, we do not have enough information for that. But we can figure some stuff out. Let's draw. I'm just going to draw, whoops, not that. I'm going to draw this radius here. And we know that it's perpendicular there. And here's what else I know. I know that it bisects, that if I draw it, that it bisects the arc, and then it bisects the chord, and that's from those ones before, remember? If it bisects one, it bisects both. So that means that this is 60 degrees, and that this central angle is also 60 degrees. So now I have a 30, 60, 90 triangle, and now I can find, at least I can find J to this middle point by using my 30, 60, 90s. If this is my hypotenuse, and that means that short side is 5, and so this long side is 5 radical 3. So I need to multiply it by 2 to get JK, so 10 radical 3 is JK. And that's all I have on these. try the homework and see how you do. We will definitely make plenty of time to talk about it in class. So thanks for watching and have a good one.